Hey everybody, this is Todd Frazee, and this is our last and largest assembly file for the STIRLING engine. So it is actually the STIRLING engine assembly. There are features on this for accessories that could go on later, but this is what will conclude the assembly work and modeling work for this course, besides perhaps designing a couple fixtures. Okay, so the STIRLING engine is going to bring together all of the models you've created, all of the sub-assembly files you've created into one big assembly. So you got to make sure all your files are gathered together in one place. And if we were to look at the drawing, we need your dash 51 cylinder assembly. We need one of those, and it has to be accompanied by every model that goes into that assembly. You need your dash 55, which is your engine frame assembly. You need one of those, and it's going to include, again, all the components that went into the dash 55 need to be in your folder, including downloaded hardware. And then we have the dash 57, which is a secondary piston assembly. So again, you need that assembly file plus its individual model files. And then some of the hardware may be that you downloaded from McMaster-Carr may be used at this level as well. So I believe some of the short steel dowel pins that were already used in the secondary piston assembly are also used in the next level assembly. So you need those files. And then you need your model for your dash 103, your 125, your 127, 129, 133, 143, 145, and then these three McMaster-Carr part numbers. And again, you may already have used a couple of those in your sub-assembly, so you should already have them downloaded. If you don't, pause this video, and you need to have all of these in a row, all your ducks in a row, in one folder before we start. Okay, so all of those components need to be in one place before you start building this final assembly. Okay, so let's go to SolidWorks. We're going to make a new file. It's going to be an assembly file. We're going to select OK. And what are we going to have as our main component? And I would suggest we use the engine frame. It's the biggest assembly. And so that's going to be the dash 55 we would bring in first. And hit open. And you should have the entire frame assembly here. And again, we're going to go up and click on showing our axes. And then we're going to pick on the assembly axis, and it'll align the axis of the model to that subassembly to this major assembly. And then we can go back and make those invisible. And I also want to make all the sketches invisible. We don't need to see those. So it looks like we had some sketches that were visible in the subassembly there. Okay, so this should look just like the dash 55 at this point. And then let's save our file, and it's going to be called S60-1 underscore rev 0 underscore T underscore Frazee. Okay, so our first component is fixed, and we are going to start building on this. So I would suggest perhaps we bring in the next most complicated sub-assembly. So we're going to go insert components, and we're going to grab the dash 51, which is our primary piston assembly. If it may ask you to rebuild, but there's our entire dash 51 assembly. Okay, and we're going to make a mate off one of these pins into the corresponding pinhole. And we want that to be concentric. And it's not really going to matter if we lock the rotation, because we're going to make another relationship here. So right now it can move around like this, but the one pin has to be concentric. Now if we select our other pin and our second pinhole, it's going to force an alignment there. Okay, so now I can go back and forth, but it can't rotate. Okay, now we're going to select the bottom pin face, and then we're going to rotate and look at the bottom of the shallow hole, and we want to align to the edge. So make sure you're getting the edge and not the face of the cone, and we're going to make those coincident and hit accept. Okay, so we now have that piece locked in place. Those in theory should press in. Alright, let's go on to our next sub-assembly, which is the secondary piston assembly. That's the dash 57. And let's go ahead and put that component in. Okay, I'm going to save first, and it's going to ask you to save everything. I would suggest go ahead and do that. And we're going to go insert component, and we're going to select the dash 57, which was the first assembly we did, and it should come in roughly orientated the way we want. And we're going to make another mate that's concentric with the piston with its corresponding cylinder. Okay, we want that to be concentric. I am not going to lock the rotation on that, because I want something else to control it. So right now this piston assembly will go up and down in there, but I can still pivot it. Okay, so to fix the pivot, I'm going to make the face of the inside of that slot on the secondary piston. I'm going to make it parallel to the face of the slot where the rocker arm connects the two. Okay, and that'll fix its place and rotation. Alright, so this should freely go up and down. We're going to leave that where it is. We're not going to constrain it any more than that, because this piston should freely move up and down in the real assembly. Okay, likewise, we're going to go and we're going to work on, so we have all of our sub-assemblies imported. And so at this point, if we were to collapse this down, we basically have an assembly file made up of 3 sub-assemblies. Okay, now we're going to start putting in the list of parts off of the dash 1 drawing. Okay, so let's go back and look at the dash 1 drawing. And so we have our 51 or 55 and 57 in place. Let's go ahead and put the 103 in. We'll just go in, we'll try to go in order by part number. So let's put in the S60-103. So insert component, we're looking for the 103. Our heating tube. Place that in space. We're going to do a mate. We're going to make it concentric. We're going to pick on the outside face, and we want to make it concentric to the inside of the bore. Okay, we're going to lock its rotation. We're going to accept that. But this can still slide in and out. That's not what we want. So what we need to do is the face that we want to align the end of the tube to is not visible. Okay, so it's really hard to see where we want to mate the bottom of this test tube to. So what we're going to do is we're going to temporarily make the piston assembly invisible. So we're going to go, and I want to highlight that is the dash 53. We're going to right click on its name, and we're going to make it invisible. So we're hiding that component so we can see down inside this piston assembly. Okay, and so this will allow us to do a mate between the end of our tube and the shelf it bottoms out on, which is there. And we're going to accept that. And then we can simply come back to our assembly we hid, which is going to show up as a black and white image, a wireframe image, and go ahead and show that component, and it'll return. Access that component without removing it from the assembly. We're going to have to do something similar when we work on this universal joint, because in reality this connector can't be pressed with it assembled the way it is. So on our list, the next component is the 125, or called the rocker arm. Okay, so we're going to bring in, and there's one instance of that. So we're going to insert components, and we're going to look for the 125 and bring that part in. Now the center corresponds with this hole here in the upright. So I'm going to spin it around, get roughly orientated the way it should be. And we're going to use a mate, and we're going to start off with an advanced mate. This is a perfect example of where you use the width command. And we're going to put our width as our width selection is the thickness of our part for the 125. And then our tab selections are going to be the inside of the slot. And that should not only center it in the slot, but pull the unconstrained part to being parallel to those faces. And we'll accept that relationship. And now we can simply do a concentric relationship between the center hole of it and one side of the center hole on the upright. Under the standard mates, we can select concentric. And we're not going to lock the rotation because this is a rocker arm. It is designed to rock back and forth. So it should pivot back and forth. So I'm going to position the rocker arm roughly centered in the downward position, and then I'm going to make a standard mate concentric between the two, which will bring them together. Okay, so that's one position in the cycle of this component. Now we're going to move on to our next component. So our next component after the 125 is the 127 flywheel. So let's go, and according to our drawing, it's the number 8, or 127 flywheel. We need one instance of it. So let's do a insert component, and we're looking for the 127. I'll bring it in, click. We're going to rotate it so the side that has the washer-like feature is facing the frame, and the spud is on the left hand, is facing away from it. Okay, so we're going to do a mate, and we're going to make a concentric mate, and we're going to select something round on this assembly. I would avoid selecting the thread, so maybe select the outside rim of the axle instead. Align in place. Now in relationship to the axle, this would not spin, so we'll go ahead and check lock rotation, and it would all spin together. Okay, we're going to drag this back out, and we need to make a mate between the front face of the axle and the face of this washer type feature. Okay, and we should be able to accept that. And we now have the flywheel mounted where it belongs. Okay, let's look at our next feature. According to our drawing, is the 129 crank piece. So let's insert components. And we're looking for the 129 crank. Okay, we're going to open that. And we're going to rotate it in the orientation that it would be facing the assembly. So that's with the washer-like feature facing forward. And we're going to mate the inside cylinder of the crank with the outside of the axle. And we're going to make a concentric orientation on it. We're going to leave the lock rotation alone. And we'll hit accept. It threw our part right in the middle there, so we have to drag it out. And then we need to mate the face of the washer feature to the face of the axle or the bearing, either one. And we'll accept that. So for now, we should be able to rotate around the crank, because we want to leave that loose so that we can get our linkages in the right position as if they would be in the cycle of the motor running. All right, now we're moving on to which component? Our next component is going to be the 133 washer, which goes on this, it gets captured by a pin that sticks into this hole here. So we're going to insert component, we're going to get the 133 washer. Okay, we're going to place that, rotate it to be more parallel to the part it's going on. We're going to mate the inside cylinder of the washer to the inside cylinder of the we'll go ahead and lock its rotation. We'll accept it. Now in my case, it buried it over here. We're going to move that to the correct side of the part. And then, okay, we're going to mate between the face of the crank and rotate around and the back face of the washer. Okay, so that piece will be in place there. Now let's go to the next component on our drawing. We are going to do the 143 drive rod. Okay, so we're going to do insert component. We're going to look for the 143. Okay. And we're going to rotate it until it's in the orient, which should be with the flat of the drive rod facing the front of the frame. Now here's an example of where we need to hide another component. It attaches to the drive, the piston shaft here. So I can't see the view because of this main post here. So I'm going to left click on it, and it's going to highlight that feature on the tree, and then I can right select on it and I'm going to make that one component invisible for right now. So it disappears. It's still there. All the relationships are still there. We just can't see it. All right, so we're going to mate the inside of this pinhole to one of the pinholes on the drive shaft or drive rod. Okay, so now we have a concentric relationship between those two parts. Now we're going to go back to advanced mates. And we're going to use the width command. And our width is going to be the width of the single tab on this component. And our tab selection is going to be either side of our other shaft. And those are going to connect together evenly. There should be a little tiny tolerance gap there.